We're going to go through the answers for period 1 first and then period 2. Please correct your answers, and if there's any questions you have, feel free to pause or ask your teacher for further help. So these are your answers to your first one. Again, I would say pause here. For your precipitates for the first one, you are adding, for your halide ion test, you are adding silver nitrate, which is AgNO3. So it's your silver ion in aqueous and your chloride ion in aqueous, which is coming together to make your solid precipitate. And that's kind of the same in all three, but you just replace the halide ion, but it is the same. So how I like to work out any of these reactions here, any of the ionic equations for these reactions, is if you just think about what precipitate is being formed. If you know the precipitate, then you can work backwards. So with our sulfate test, we're looking at barium sulfate. You know that's the barium meal that you have for the gastrointestinal tracing. And you know it's going to be solid. Light can't pass, the X-rays can't pass through it, and that's why it comes up in an X-ray. So it is barium sulfate, which is BaSO4 solid, and then you can work backwards from there. And then barium, which is 2 plus, sulfate, which is 2 minus, and they're both aqueous. Okay, so you can always work your way backwards here. The only one that's the next one is quite hard to work backwards. Your carbonate, it's quite hard to work backwards here. So you just have to know that you have your hydrogen ions from your acid, which is aqueous, and that reacts with your carbonate ions. And you just need to remember that it always reacts carbon dioxide, as we know, because that's the effervescence. And then you just have to remember that you have water produced there. Then afterwards you can balance the equation. If you've got 2 hydrogens in your water, then you know you're going to have 2 hydrogens on the left-hand side as well, 2 hydrogen ions reacting with that. The next one, again, your ammonium, that's quite hard to work backwards with. But again, you know that for your gas that's produced, in this case it's ammonia, you're going to get it formed from your ammonium ions are going to react with your hydroxide ions in aqueous, and that's going to form ammonia gas, and then you're going to have another product here, water. Okay. This reaction here doesn't need balancing, so it's quite straightforward as long as you remember that you're always going to have ammonia gas, because that's what we're testing for with the damp red litmus paper, but you also get water as well, and that's liquid. If you're having problems remembering these, I would suggest just writing flashcards for them with the test and then the ionic equation as well, and that could really help you. For the next tests, this is when you add your sodium hydroxide to your 3 different types of ions. Again, you're adding your OH minus ions to test for your 3 metal cations, and you're going to get a metal hydroxide formed. So as long as you know that you get a metal hydroxide formed in each of these cases and what colour they are, you're fine here. But you can work. This is one you can work backwards with if you know it's copper hydroxide, or iron hydroxide, or iron 2 or iron 3 hydroxide, and they're all going to be solid because again they're precipitates. Different coloured precipitates, and then you can work your way backwards there and just balance. Make sure you are balancing at the end there as well. So you've got 2 hydroxides in the first 2 instances, and then 3 hydroxide ions in the 3rd instance. So here I'll go over 2 answers first. Let's go over ammonium carbonate and then maybe calcium hydroxide, and then we'll see what the answers are. So ammonium, I know that is NH4+. You need to know that out of your head. It's a molecular ion, we're going to go golden 5. Same with carbonate, it's a golden 5. So you need to know it out of your head. Now the charge tells us the valencies. We've got 1 there and then 2 there. So we've got a valency of 1, valency of 2 there. So that means we're going to have 2 ammoniums and 1 carbonate here. So 2 ammonium, so NH4, because it's in a molecular ion, I've got to put brackets around it, 2, got 2 of those, and then 1 carbonate. Okay, and we don't include the charges there. And then for calcium hydroxide, we've got calcium is in group 2, so it's Ca2+, and hydroxide, and it's a molecular ion, and I know that out of my head. We look at the valencies, 2 and 1, and then if that means we're going to have 1 calcium and then 2 hydroxides. So 1 calcium and then 2 hydroxides. I know I need to put that into brackets because it's a molecular ion. And again, I don't include the charges. So these are your answers here. Let's just put those out. But these are your answers. Please do correct them. That leads us nicely on to calculating, working out the formulas for these solutions. They're all solutions, I think, actually, except for ammonia. So you can see here that they've all got state symbols of aqueous. Ammonia is gas. Let's see if we can include that gas there. So I put here that all acids and alkalis are aqueous. So your nitric acid and your sodium hydroxide there, they're going to be aqueous, and your hydrochloric acid as well. They're all going to be aqueous. Your solutions as well, your calcium hydroxide solution, that's going to be aqueous because it's solution. And ammonia is a gas, that is always going to be a gas. That's going to be a gas if it's ammonia. Silver nitrate is a solution, so it's going to be aqueous. And barium chloride solution, that's going to be aqueous as well. And you should remember the solubility rules as well. All chlorides are soluble except for your lead and silver. So here I've actually recorded my observations here, as well as stating the positive ion. So blue precipitate with sodium hydroxide is copper 2. Your flame colours are there. D actually failed all cation tests, and then adding your sodium hydroxide to E and F, you had a green and a brown precipitate. Now, I think I did mention that I do like to remember these as, if it's green, it's got two E's, therefore it's going to be Fe2+, and then brown, this W looks like a 3 lying down, so it's going to be Fe3. That's how I like to remember it. Anyway, the way I write brown anyway, it kind of makes sense because you can see it looks like a 3 lying down. So your negative ion, you've got sulfate. You've got a halide ion test for B and C. D failed all anion tests. And then you've got another sulfate test. So you've got, I've put here two different sulfate tests. Okay, no matter what you see in the video, it doesn't matter. I just put these here just to remind you that actually you can have two different sulfate tests. You can either have nitric acid with barium nitrate and hydrochloric acid with barium chloride. Doesn't matter which kind of negative anion you go for. It could be the chlorides or it could be the nitrates. Both of them are soluble. Both of them are soluble salts. So your white, so don't really affect the result. You couldn't use sulfuric acid and then barium sulfate because you will definitely get then a positive result for sulfate ions, but you can use these two, chlorate and nitrate. But as long as they're pairs, you don't want to introduce any new anions. So you don't want to mix nitric acid and then barium chloride because you'll be adding nitrates and chloride ions. So you don't want to add in as many anions as possible, at least as possible. Your salt names are pretty easy from your positive and your negative ion. Okay, D is actually water. Don't worry if you didn't get it, but you can just write it in now. And the formula then is quite easy because that's what we've been doing before. So you had some recap of that, and I've put those here. Okay. Now notice that with your iron 2 sulfate, you don't need to put any Roman numerals here because it kind of, you can automatically assume that this is iron 2 nitrate because of the formula, because sulfate is 2-, and then that means that if there's only one ion, this is definitely going to be 2+, okay, because of the 1-to-1 ratio. Okay, so we're going to look at the answers here now. We're going to be finding out what A, B, and C are. A, B, and C. Okay, so A is an orange-brown orange solid. Yep. When sodium hydroxide solution is added, so we're looking for our copper or iron 2 or 3+. Solution of A, an orange-brown precipitate is formed. Great. The W lying down tells us it's iron 3. So W lying down looks like a 3, so it is going to be iron 3, and it is hydroxide. Great. That's B. Adding dilute nitric acid, okay, and silver nitrate, that is going to be our halide ion test. So it's either going to be chloride, bromide, or iodide, depending on what colour it is, and white is the lightest, so it's at the top, so it's going to be chloride. So C is a white precipitate, that is going to be silver chloride, the silver chloride, and silver chloride, perfect, that's white. Now that just tells us now what A is. A is going to be, because we had a positive iron 3 test and a positive chloride test, so it is going to be iron 3 chloride. Iron 3 chloride. Perfect. Okay, it says write equations for ionic. I'm going to write ionic because it's a bit easier. We can work our way backwards for these reactions. Okay, let's see what we got here. So let's work our way backwards. So we've got iron 3 chloride. That's Fe, and then Cl. We're going to have 3 there because we've got valency of 1, valency of 3, and we swap. So we're going to have 3 chlorides and 1 ion. So FeC3, that is a solid. We're going to work our way backwards. We're going to need 3 chloride minus ions, that's an aqueous, plus our iron 3 plus, and that's going to be an aqueous as well. Fantastic. So then our next one, iron 3 hydroxide. Again, we can work our way backwards here. So we've got FeOH, and it's iron 3, so we're going to have 3 of those, and that's just because OH is minus, so we're going to have valency of 1, valency of 3. Again, we swap. It's the same for the above. Okay, so quite easy there. And then again, it's just going to be the same. So they're going to be aqueous. We're going to have 3 hydroxides, then iron 3, and that's going to be in an aqueous solution as well. Silver chloride, Ag always has a valency of 1, and then our chloride always has a valency of 1 as well. So because it's in group 7, Ag is a transition metal. You can't know it by the group, but you just remember that it is 1. We don't tend to put 1 here because it pretty much always is 1. So it's not like iron, which forms 2 and 3 ions. These are solids. I forgot to put it. So we've got solid there, and then you've got your chloride ions. So minus, they are aqueous, and you've got your Ag ion, your silver ion, and that is again aqueous. It's already balanced, so this is a 1-to-1 ratio. Okay, so again, I'll go through these quite quickly. We've got D, E, and F. So we're going to give the names, and then we're going to do an ionic equation for them. So we've got D. I'm just going to highlight some of these things quite fast. We've got green precipitate for E. So E is going to be iron 2 hydroxide. That is the only green precipitate, and you should be remembering that now, which turns orange-brown around the top after standing in air, and that's probably because it's oxidized to iron 3 after standing in air. Addition of dilute hydrochloric acid and barium chloride. This is our sulfate test. Decision D gives a white precipitate. This is a positive sulfate test. It gives solution of D gives a white precipitate of F. So F is going to be your barium sulfate. Barium sulfate. Fantastic. So D, therefore, is going to be, we had a positive iron 2 test and a positive sulfate test. So it is going to be iron 2 sulfate. Okay, so now your ionic equations. You've got your iron 2 plus your sulfate. That reacts to form your iron 2 sulfate. It's a 1-to-1 ratio. That's great. We've got 2 valencies there, and that just cancels out into 1-to-1. So it's the perfect ratio. It balances out. So then we have iron 2 plus hydroxide reacts to form iron hydroxide, and there's 2 there just because we've got valency of 2 and 1. So we cross. We've got 2 hydroxides, 1 iron. You can add in the state symbols here, as you already know. These are going to be aqueous, AQ, sorry, I forgot to put those. And then these are, because they're precipitates, they're going to be solid. Okay, but excuse my handwriting. We have barium, which is in group 2, so it's Ba2+. It is aqueous, plus your sulfate, SO4 2-, and you should be getting the hang of the molecular ions and remembering them. Reacts to form your barium sulfate. Now it is a 2-to-2, exactly like in our iron 2 sulfate. So it's BaSO24. Now remember, we don't include the charges in there, and that is solid. So now you can probably get the hang of this now. You're just looking for the positive tests. We've got the positive tests and just kind of seeing what ions we get. So dilute nitric acid to give a colourless solution, yes, H, and a colourless odourless gas. So a colourless solution, which is H, and a colourless odourless gas, I. This is going to be carbon dioxide, which turns lime water milky. Fantastic. G has a lilac flame colour. So because it's got a lilac flame colour, we know that this is potassium something. potassium. Oh, it's going to be potassium carbonate because we had a positive carbonate test in our carbon dioxide. So potassium carbonate. Oh, so we've got a positive potassium test and a positive carbonate test, and then we're finding out the name of H. So G is a colourless crystalline solid, which is potassium carbonate, which reacts with dilute nitric acid to give a colourless solution, H. The colourless solution is going to be potassium carbonate. It's going to be potassium nitrate. So you can write it out here if you need a help there. Potassium carbonate plus nitric acid. Now, if you add an acid plus a carbonate, you're always going to get salt. The salt is going to be potassium nitrate. Potassium nitrate. You're going to get carbon dioxide and water. So your solution is going to be your potassium nitrate. I'm not going to finish off the equation there, but we are going to have potassium nitrate here. Remember, all nitrate salts are soluble. Okay, so it asks for ionic equation as well for these. So let's give it. Okay. So it only wants to do it for G, so dilute nitric acid and G, so potassium carbonate and nitric acid. So with the acid, it's our hydrogen ions that are involved, and they're going to be reacting with our carbonate ions, and that's going to form carbon dioxide, as you know, and it's also going to form water. The water's liquid. Sorry, that's really bad, but it is liquid, and carbon dioxide is gas. But these are going to be aqueous. Now you just need to balance them. You're going to have two hydrogens, which you've got two there, and that's balanced. So again, we can do the same here. We're looking for JK and L. JK and L. We have J is a colourless solid when it's warmed up with sodium hydroxide solution. So warmed with sodium hydroxide solution. This is an ammonium test, produces a gas K. That gas is going to be ammonia gas. Ammonia gas, which turns damp universal indicator paper blue. Great, that's a positive test for ammonium. So J is going to be ammonium something. So we've got a positive cation test. I've just kind of botched the spelling there. Ammonium. And let's find out what the anion is, followed by silver nitrate. Okay, this is a halide test. It's added to a solution of J, a cream precipitate. So we go from white, cream to yellow. So white, cream, and then yellow. So it is going to be bromide ions. So ammonium bromide. Perfect, great. L is formed, and that is going to be silver bromide. Silver bromide. Okay, what does it need? An ionic equation for the formation of the cream precipitate fat. Thank you. That's only this, the cream precipitate. So that is going to be Ag plus Br minus, reacts to form AgBr. That's solid. Okay, always, if you ask for an ionic equation or whatever, always include state symbols. You can see the textbooks and the textbook answers here. That might be quicker for you, so please do pause and copy them down if you want to. Okay, it might help just reading some of these. That's again if you